So today I'm going to talk about the Software Sustainability Institute, which is a relatively new institute in UK, and what it does for research software and why we need such an institution. So let me begin with a brief introduction about myself and my experiences. Since 2015, I'm a fellow of the Software Sustainability Institute. I run a small IoT business since 2013. I'm still having a research group at the University of Cambridge where we develop software, mostly around data analytics, machine learning. And I was a scientific advisor to a scientific database and also the program leader for a teaching program in computational biology. So the Software Sustainability Institute is government funded. So the government gives money to a funding body, and the funding body has decided to use that money to create a virtual institute. And we're looking into making better and more sustainable software for scientific purposes. It's primarily focused on academic software, but if you are an industry stakeholder, then the Software Sustainability Institute is open for that as well. It's a distributed team with a few members across several universities where we occupy just a few offices, so there's not a building for the institute. And there are about 40 or so fellows like myself from different fields in academic research who go out into the field and who see the things that are happening in the research software every day. So we want good, reusable code, and that is not a given in academic software development. We want it well documented, and from my own experiences, I can tell you that documentation is usually, it happens by accident, but not really because you plan for it. Software has very often a problem in academia because it is not really considered a research output. You're just considered somebody who makes a tool. You're a tool developer, and as such, you have very little credit, and that needs to change because effectively, with that sort of treatment, you're driving the good people out of software in academia, and you drive them into industry to do something where they probably get better pay and greater recognition. We value reproducibility and openness. So wherever we have the chance, we preach open source, open access, open data. And we try to raise awareness, like I do here, telling you about the Software Sustainability Institute and why it needs to exist, and we also establish facts. So these are some of the facts. So in a survey that the Software Sustainability Institute held about 2 years ago, they asked different researchers in different areas of research. So could be biology, could be geology, could be climate research. Do you use research software? So I'm not talking about your generic office package that you use to write a paper, but do you have dedicated research software? And 92% of researchers say yes. So then the question is, well, what would be the impact of you not having that software? And about 20% of all research could just not happen. So you take software away, and these fields do not exist anymore. And that is quite significant. For a further 70%, doing research would mean a lot more effort. So rather than using a dedicated software, you'd have to reformat all of your data and probably do it in an office package, something like that. And only 10% of researchers said that, well, if the research software was gone, it wouldn't make a difference. So there's clearly an impact that research software has. Quite surprisingly, more than half of those researchers who use dedicated software also develop software themselves. And when the question is, have you received training in software development, 80% say yes. Now, that is a slight exaggeration, I would say, because some people consider visiting Stack Overflow twice a day training. And so there are things to be done. So, as all of you probably are aware, software reaches certain boundaries. If you have a small project, you can probably tackle it yourself. But as soon as software reaches a certain size, and you need to share it with other people, or it's so large that you can't really keep your 7 parameters in the top of your head yourself, you need to have good practices to implement good software. So the Software Sustainability Institute tries to provide the expertise and services to academics and to people who develop research software. So that could be, they provide software reviews. So you can ask the Software Sustainability Institute to send an expert and have a look at your code. And then give recommendations of what should happen with the code base. So one example is a case where there was a widely used software in a particular field of science that dated back to the late 1970s. And effectively, on the recommendation of the Software Sustainability Institute, the entire code base was shifted from, I think, Fortran to something else, and was made entirely open source and now resides on GitHub, which is a big win for the community. So they established collaborations between stakeholders, and this is essentially one of the reasons I'm here, because I want to talk to the Eclipse science branch and see whether there are any opportunities for collaboration. They give guidance and best practice on software development. They provide training. So I don't know if many of you have heard of the software carpentry workshops, but these are usually very intense 2-day workshops where people come in and really give you very hard hands-on exercises, but you leave with proper skills. And those workshops are organized in the UK through the Software Sustainability Institute. They give insight in project management, help community building, and do publicity. So yeah, that's why I'm here. I hope we can work better and we can work together. And we just need to scope out what our options are. So for example, the Software Sustainability Institute is a national institute in the UK, although the problems that academic software is facing must be the same very much worldwide. At the same time, the Eclipse Foundation has a huge reach in comparison to the Software Sustainability Institute, and we need to see how we can combine that. So, what are the issues with research software? I don't know how many of you work in an academic context, but I just wanted to give you, based on my own sort of experiences over the last 2 decades, I wanted to show you the things that typically go wrong. So this is exemplified by the honest account of and anecdotes of bad coding, bad design decisions, and bad practice. So to give you a little bit of my coding background. So by training, I'm a biologist. And so coding was never really part of my formal training. Back in the early 90s, I learned Turbo, Pascal, and Prolog in school. Then in 1995, I became a Windows developer using Delphi. And I think my training back then was Control F1 to learn about the syntax of certain functions. Then as a postdoc and later research group leader, I switched to Perl, R, and SQL. And essentially, the daily Google search was my training. And since 2010, I picked up a few more skills. But again, never with proper formal training, but really on an ad hoc basis. And that makes the very difference between me and someone who is a trained software developer. My first research paper that I published was about a software. That was when I was still an undergraduate student. So it was totally unsupervised, I was based in a lab as the only person in a team of 15 biologists who knew how to program. There was a PhD student with a particular need, and I said, well, I can help. So he communicated what he needed, what he wanted. I sat down, I wrote the software. There was no help, there was no software manual for this software when we published it. And I still wonder what the use of that was. I mean, we got it out there, we got it published in a journal, but I'm very sure that in the absence of any explanations, nobody was ever able to use it. Quite generously for the time, so that is like back in 1999, we said that you may obtain a free copy of our source code upon request. And I really felt like, you know, a very good person sharing my code. There were 0 requests for it. And just for the fun of it, I tried to retrieve the software the other day, and the URL, of course, is long dead. And so that's gone. And I mean, it's probably not bad for this software to be gone, but this is what happens very often to research software. Like, you know, you stumble over a URL in a scientific paper and you think, oh, this software might be quite useful for my purposes. But then you get a 404, and that happens more often than not. So my next software example is something that I developed as a PhD student. So I had a particular scientific problem for which I just wrote the software to get a particular job done. And only later I decided that I should probably try and also publish the software and share it. The code was a horrible mix of object-oriented and spaghetti code. So the Windows environment forced me into object orientation, whereas essentially my mindset was very much still 10 go to 20, 20 go to 10. And I think that the worst crime in this software is I distinctly remember that I needed to search for the index in a key value data structure. And as I was too lazy to program a function for that, I took a visual component, set its parameter to be invisible, but it offered in its background the functionality that if somebody typed code, it would retrieve the index in a search field. And that's essentially hidden behind the actual GUI, because that's how you do things, right? Not with sharing in mind, but essentially just to get a job done and you cannot be asked anymore. Also, it required complex manipulations in the source code to update any user settings. And this is a big no-no, because as an academic researcher, you have to keep in mind that most people who use your software will not be programmers, right? I got many requests for the code, and I even sent it out, usually with very apologetic and lengthy emails. But I was, and I still am, too embarrassed to put it on SourceForge or these days GitHub. So yeah, this is academic software development as it happens every day. There was another thing. At some stage, I thought it was great, really, to develop software for the machines that I'm using. And by the time I had changed to the Mac, we were even proud to share our code this time. But we wrote it in Objective-C. Nobody in the academic community knows Objective-C. I think we had about 1,200 software downloads, and we had two code downloads. So, like, you know, there's like if you write it in Swahili or something, people are just not interested. Now, this is something which is not really related to software development, but that's another bad academic practice. So, in your materials and methods section, where you are asked to describe what you did and how you derived your research results, typically it should go into so much detail that people can pick up your material, your sample, whatever, repeat what you did, and hopefully come out with the same results. Now, this is taken from 3 papers that I published between 2005 and 2008, and I have to say, I'm not proud of that. Blah, blah, blah. Analyses were performed using custom-written Perl scripts. No URL, no nothing. It's just like, I wrote some Perl scripts, right? One more. Blah, blah, blah. Downstream analysis were performed custom-made Perl scripts, and here more analysis was performed using custom-written Perl scripts. And, well, statistical tests were performed with R, but I'm not telling people what sort of statistical test, what syntax I used, what parameters I used. And, well, that might be a domain-specific problem, but as a biologist, the reviewers would pay a lot of attention that I describe the biology in very much detail and make it possible for people to replicate exactly what I did in the wet lab. But when it came to the computation analysis, there's very little interest really, even by the reviewers, to see whether that all makes sense. So essentially all these 3 segments are more or less like, well, I cannot be asked writing it down what I actually did. And that's just very bad science and should not be done. So things have changed, thankfully. And well, I was keen and eager to learn, and I think I have learned. So these days, as I said, open data, open source, open access, and open science are really accepted in many fields as the default. It varies. So in the life sciences, for example, these are values that many people share and have. In other fields, that sharing thought has not really penetrated the heads of those in charge. And I say, well, our first really big data sets that required computational manipulation came up in the mid-90s. Already by the beginning of the 2000s, people got together and said, well, we need to tackle this problem because one day we're going to end up on a huge stash of data and nobody knows what to do with it. So let's share our stuff. And when we work with data, let's also share our tools. And that's now slowly happening. And now we have essentially accepted platforms for data exchange. We have accepted platforms for metadata. We have descriptions of metadata that people use. But only really since the early 2010s, there's increased pressure not only to then publish your data, but also publish the tools along with that. Sometimes journals request it. Very often the reviewer would say, well, this is all great, but can you please show what code you used in order to generate that table? And what's becoming more common, and I really like that, is frequent naming and shaming of people on Twitter. And, well, if you had a shitstorm once, you try not to do the same mistake a second time. So that helps. But even if you try to do everything okay, there are still traps. So I'm in the field. I was quite well known for a particular database that I had developed. Developed not so much in terms of the technology, but the content. But when I first shared the data set, it was a simple Perl CGI script with a MySQL background. It was very easy for me to update the content because it was just an update of the table in MySQL. But the software or the website itself had no analytical capabilities. And at some stage, I thought, well, I have this rich data set, and I want to provide added value for people to use this data set. And also, it's easier to publish something if you can say, hey, there are new features, right? So I used a quite complex framework. It's powerful, but it's awfully complex. It's based on Java, active server pages, Ajax, Postgres, etc., etc. It took me it took two specialists in my research group to put it all together. When they left, I realized I had great fancy features and super looks, but until now, I haven't figured out how I can update the content, and so the database has not been updated for the last 3 years. So you need to keep the right balance between good software practice, and actually having it practical. So the state of the art now is that when people come to my group, one of the first things is that they learn how to use GitHub, and that we also put our stuff onto GitHub before we publish. So, because what we are developing, and even if it's like, you know, a clever routine, it might be useful for somebody. And we try to develop stuff that is hardware and OS independent. We do GUIs, but at the same time, the tools should also allow for config files, so you can run it in headless mode or in cluster. There is extensive documentation for end users, and the end users may have a different focus on your software than the people who want to develop your code further, so that's a separate document. And what really impressed me, and this is something that I had not thought about, is that at some stage, my postdoc started refactoring the code because he realized that, so this is like a framework written in Java, that there was a lot of sort of replication in, or redundancy in the way things were named. And he thought by just rewriting certain classes, he can shorten those names and make them more intuitive to use. And this is something that really impressed me. So in summary, the issues with mostly academic scientific software development is that there's no dedicated budget for software development. So I can ask the funding bodies for thousands and thousands of pounds to do certain experiments, but when I say, can I please have a dedicated programmer on the team, they will say no. Of course, there's still this mindset that software is something that you just do, like it happens, you know. You boot up your computer and software is there. Even if it's funded, very often they would say, well, you know, we can give you a programmer for 3 months. Now, you best believe that that programmer will be busy implementing till the very last day. So again, documentation is probably not the first priority. Software is typically very ad hoc, not really with reusability in mind. And that is also something that needs to change because, I mean, if we all invest a certain amount of time into writing software, these are like, you know, thousands of hours of wasted effort if nobody's going to pick it up again. There's no credit for writing good software. So, I mean, in a way, I even got credit for doing my awful data manipulation with this Windows software. The code's generally generated by amateurs with a high turnover in the lab. So, like, you know, somebody who has no clue about software development and good practice writes some code, hands over the code to the next person who has absolutely no clue about proper software development, and weird things happen. And one very big issue is that academic salaries are really poor compared to industry salaries. And if you happen to find somebody who has the skills, they usually don't last very long. They leave because they can easily earn double in an industry context. I have no suggestions how to tackle that because things are as they are, and there is very little money for research and academia in general. But at least in these points up there, I think this is where the Eclipse Foundation and the Software Sustainability Institute might be able to work together and probably look into new ways of informing people who write academic software and also provide help to a certain degree, may it be in workshops, may it be in probably actual hands-on help, or just by mediating and facilitating contacts with people in the foundation. So we should work better and together. And I think nobody's going to do it for us. And probably the people who drive those developments are sitting right here in this room. And this is where we should get the conversation going. And we need to scope what our resources are and how we can probably best combine them. And I'm finished. Thank you. Any questions, suggestions?
There's one. Maybe one remark, because your story is not overly optimistic.
It's getting better.
Yes, but maybe just one comment. You mentioned R, the bioconductor project, which you obviously know. In Austria, there was a scientist, Friedrich Leich, who is an R core developer. And he was once the most cited scientist in Austria, thanks to his bioconductor paper.
Yeah.
So there is a way to get recognition for published open source software.
Yeah, it's happening now, and especially in the biosciences. So that is true. There is a particular branch within this R statistical framework, and before they take on any packages, the package is actually reviewed by other scientists, and they make sure that the vignette is proper and correct, that it runs with demo data, so you actually need to provide unit tests. And this is probably where some of these good practices have already started to make a change.
Another example is specific scientific journals that target scientific software. For example, the Journal of Statistical Software is a journal really made to review and publish statistical software, and in terms of impact factors, it has been rising incredibly.
Okay.
So it has also established itself as a dedicated journal for publishing scientific software with peer review and so on. So there are definitely a lot of positive signs as well.
Yes, that's true.
In spite of things you mentioned and that I do recognize.
So I don't know about that particular journal, but I should say that the Software Sustainability Institute actually maintains a list of journals who have dedicated software sections or dedicated to research software. Some of them are relatively generic, and others are more domain specific. But certainly there are platforms, and if you have something that you think is worth sharing, and even when you work in an industry context and your employer allows for that, it's always worthwhile sharing that knowledge. Yeah?
Don't you think that instead of teaching scientists basically the industrial programming practices, it makes sense to explain them how to write code in some kind of silver bullet thing like Mathematica, for example? Which will, to me, this solves like almost all of your issues that you had in your bulleted list on the last slide, because it's such a science-friendly tool with, the adoption rates is booming and so on. But in the context of your presentation, it actually implies that quite orthogonal coding practices to, like Java or Python or R or something like that. So it's a totally different concept of programming altogether. So do you think it makes sense to teach them this one rather than?
Well, I guess these days, at least in the teaching that I was involved with, R is really the first skill that people learn. And I mean, in a way, it's like, the open source Mathematica. Yeah, I know, with constraints. But I mean, the problem is that it's just not a one size fits all. And there are certain problems you just cannot tackle with R. And you can write bad R code. I mean, I speak of myself here.
Yeah,
Okay. Good, thank you.